What's poppin', dogs? Mr. Allen here with some simplifying of radical expressions in this video. And I got 4 examples, 2 different types of each. 2 without a coefficient out front and 2 with a coefficient out front. So let's start with the square root of 40. I'm going to break this thing down with a factor tree. And I like to do this with prime factors. You can also look for perfect squares. I'm actually going to show you guys both. So to start, I'll go with the prime factors. I'm going to divide by 2 until I can't divide by 2 anymore. So I got 2 and 20. 2 and 10, 2 and 5, all right? And I can't break down 5, it's prime. And I'm gonna look for my pairs, so a pair of 2s comes out, boom, 2 comes out front. And then the 2 and the 5 is not a pair, so it goes back together inside the radical. Multiplication puts them back together because division took them apart, okay? I was breaking this apart with division. I gotta put it back together with multiplication. This is the simplified form. And if you're ever wondering, like, hey, did I do this right? You can plug in the square root of 40 in your calculator, plug in 2 root 10 in your calculator, you'll get the same decimal, all right? Now, I did say that there's another way. I'm going to talk about why I prefer this method after I show you guys. So there is another one. I'm going to do this in, we'll go purple. Okay. So instead of going to prime factors, I'm going to look for my biggest perfect square. I can divide 40 by 4. Can I go bigger? Not 9, not 16, not 25, that's already over half. So 4 and 10. So 4, 10, the square root of 4 is 2. I cannot square root 10. Boom, got to that. And that's actually really, really fast. Faster doing it that way than this way. But the main reason why I prefer the factor tree is once we go into cube roots, fourth roots. If this was the cube root of 40, I'd take out a group of 3 2s. If it was the fourth root, I'd need a group of 4. All right, and you can think about perfect cubes and perfect fourths, but not everybody knows those off the top of their head. Sometimes the prime factor tree is just the way to go. Totally up to you guys. You can do either one. I'm going to continue to show you both, and you can choose which one you want to do. All right, moving on. Let's go with pink on this one. Actually, you know what? No, I'm going to stay with the same colors, so I can show it like the factor tree, the prime factors, and then the perfect squares, blue and purple. Okay, so for 108, start by dividing by 2. I got 54. Divide by 2 again. That's, what is that, 27? I cannot divide that by 2, so I'll go to 3. And I get 9, 3, and 3. So now I'm going to look for my pairs, okay? Pair of 2s, pair of 3s. So those come out. 2 times 3, which is 6. The root 3 stays in there on its own. So there's my final answer, 6 root 3. All right? You might be wondering, like, wait, why do the pairs come out just as a single number? Well, 2 times 2 is 4, and the square root of 4 is 2. 3 times 3 is 9. The square root of 9 is 3. So the 2 and the 3 came out and got multiplied together to become 6. Over here, 2 times 2 is 4, but the square root of that is 2. So when I take it out the square root, I'm taking the square root. All right? So let's try it the other way here. Square root of 108. If I break that down into perfect squares, let's see here. I could divide that by 4. I could divide it by 9. Wait, what about 36? I could divide this by 36, and I'm left with 3. Square root of 36 is 6, root 3. Same answer. Very quick if you know your perfect squares, and you can divide by them easily. Otherwise, factor tree. Okay? Cool? Awesome. All right. Next one over here. 4 root 52. Well, it's going to start the same. I'm going to break this thing down, okay? So I'm looking at 2, and then I have 26, 2, and 13. So a pair of 2s, that's going to come out. 2 comes out and gets multiplied to that 4, giving me 2 times 4 is 8, square root of 13. Boom. All right, there we go. And if you were to do it, again, with just the perfect squares, I'll just break it down this way maybe. That'll be easier. I would divide this by 4, be left with 13. Square root of 4 is 2. 2 times 4 is 8, root 13. Okay, same idea, but I'm just looking for that perfect square, a 4 in this case, rather than prime factors of 2, 2, and 13. And the last one, last but not least, we got 3 root 300. Well, I'm going to break this down. If I go by 2s to start, I'm looking at like, right now I really want to do it just the other way here because I can see that 300 is divisible by 100. And that's a perfect square. But we'll go through the prime factors, okay, just for systematic approach. 2 and 150, 2 and 75, I can divide this by 3, and I'm left with 25, and then we get 5 and 5. And you don't have to go by 2 straight through. I just do this from an organization standpoint, okay? If you see that and you're like, I want to divide by 3 first, go for it. More power to you. But I just do 2s till I can't, then 3s if I can, then 5s, then 7s, 11s. Just going through with my prime factors in numerical order, least to greatest, because now I got my 2s right there, got my 5s right there. Everything's nice and organized down this like line right here, so I don't miss something, okay? If you start breaking it up and you get a whole bunch of things all over the place, you might miss some of your prime factors at the end of those. That's why I like to go with that systematic 2s, then 3s, then 5s, so on and so forth. So now I have 2 comes out, 5 comes out, all that multiplies to the 3. 2 times 5 is 10, times 3 is 30. And then what's left in here? Just the 3, root 3. And as I was saying earlier, but I really wanted to just jump to it, which was this can be broken down into 100 times 3. Square root of 100 is 10. 10 times this 3 out front is 30. This 3 right here is going to go back inside the radical for a 30, root 3. Boom. Bingo, bango. That's about it, man. That was radical, bro. All right, that's the last time I'll do it in this video because the video's over. Thank you guys for watching. You're awesome. And radical, I lied one more time. Stay dope.